or calculators? Because I don't, so I need your calculator prowess to help me out today. All right, we've talked about parallelograms. More specific parallelograms were the rectangles. So we talked about rectangles. So they are also parallelograms. A rectangle is also a parallelogram, but it had right angles and congruent diagonals. So today we're talking about rhombuses or rhombi, and we want to be able to identify properties of rhombi and use them to solve problems. What's a rhombi? What's a rhombus? Okay, like a diamond. Yeah. Okay. So two triangles next to each other. Yeah. So a rhombus does usually, I think, denote sort of a diamond type of shape. Paxton said two triangles, so that's imagining here we have two triangles next to each other like that, yeah. So a rhombus is yet again another special parallelogram. So rhombi have all the same properties of a parallelogram. So tell me more about parallelograms. What do we know right from the name? Parallel. We've got parallel sides. Two pair of parallel sides, okay? If they also have parallel sides, then they must be the same length too. So opposite sides are also congruent. Opposite angles are congruent. Now, this is not a rectangle. All right, so a rhombus is not a rectangle. And so the angles aren't 90 degrees. We need to remember that. But the opposite angles are congruent. So here we have opposite angles that would be marked the same. And over here we maybe have some different angles that are supplements. So consecutive angles are supplementary. So that's important to recognize. If this angle is 80 degrees, what's this angle up here? 100. All right, so 80 and 100, they add to be 180 degrees. And also, just like a parallelogram, the diagonals bisect each other. So they're split into two little baby pieces, two little congruent babies, okay? But they're not the same length like in a rectangle. Now, a rhombus has a few extra things that we want to make sure we understand. It turns out, not only are the opposite sides congruent, but actually all four sides are congruent. All four sides are congruent. So these, all four sides happen to be the same. So if this side is 7, what's this side over here? 7, 7, 7. All four sides are the same length. So that's good to know. Now, here's a very interesting thing. Diagonals are perpendicular. That's a big one right here. If I connect my diagonals, they are perpendicular, so they intersect each other at a right angle every single time, which is really pretty amazing. That's kind of cool. So we get a right angle there. And then let's see. So if we have a right angle, what formula is floating through your brain? Interesting. Maybe. We have little triangles, little baby triangles here. On a right angle. Pythagorean theorem, sure. Yeah, a squared plus b squared equals c squared. Again, we have a right angle, so we have a hypotenuse here, and we might need to use that theorem again. So that's always a good thing to think about. Also, diagonals bisect. Bisect, what does that mean, bisect? Cut it in half, yep, 2 equal parts. So diagonals bisect opposite angles. Now that's a really interesting one. So these opposite angles in my picture that I drew were 80 degrees each, but it turns out that the diagonals, because all my side lengths are the same, that diagonal is going to get bisected, and so that angle, that diagonal doesn't get, well, the diagonal does get bisected too, but the angle itself gets bisected. So each little side of the angle gets to be 40 degrees and 40 degrees. So those opposite angles are going to be bisected into little 40-degree pieces there. So again, it's good to have a little picture that's just to sort of remind you of every little nuance there, okay? So pretty interesting. Okay, let's look at number 1. Each quadrilateral below is a rhombus. So, I mean, I think the really important thing for rhombus is parallelogram plus 4 congruent sides, really. I didn't grow up with the word rhombus. I don't know when rhombus came to being, but I didn't learn rhombus. I don't know what we called it, but for some reason, I do not remember learning rhombus in geometry. I don't know why. I had a great geometry teacher, but I don't know. It's weird. I have no recollection. Like I blocked it out. Okay. All right, it is a rhombus. So I know that I have all 4 congruent sides, so I definitely want to keep that in my brain. And I also know that those little angles get bisected, so I'm going to make a little note of that too. That might be helpful to me later. Let's see, JK is equal to 12, and JN is equal to 7. All right, tell me what else we know from this picture and just that info. All right. All right, everything is 12 all the way around. What else do we know? NL is also 7. Excellent. Okay, so JM is 12, JL is 14, MN. Oh, no, the diagonals are not congruent, not a rectangle. So, let's see, what else do we know here? Yeah, well, you need the Pythagorean theorem. We know that the diagonals are perpendicular. So I have a right angle right here. You should draw that in. In order to figure out MN, I really need to know these little pieces here of the diagonal. I have this lovely little triangle right here. So I need to figure out that little piece, which I'm going to call X for now. So leg squared plus leg squared, 7 squared, equals, my hypotenuse turns out to be 12. All right, so in all of these triangles, I'm trying to figure out this little X here, this little segment MN, leg squared plus leg squared, because my right angle is right here. 12 is the hypotenuse. All right, so know where those right angles are. Let's see, we have X squared plus 49 equals 144, and then we need to subtract 49, which is 95. Thank you. And then we can square root both sides, so we get X equals 9.7. All right, so each one of those X's is 9.7. So MN is 9.7, which means MK would be 19.4. And how'd you get 19.4? Yeah, 9.7 times 2. or 9.7 plus 9.7. Excellent. Okay. Let's see. You think you're ready? Let's look at, I think that's it. Let's go to 4. Let's look at number 4. All right, lots of angle measures here. Again, I think the best thing to do is really to draw on your picture, right? So we have a 38-degree angle. What do we know about these little baby diagonal opposite angles here? What do we know about those little baby angles? They're bisected. So 3 must also be 38. And opposite angles are also congruent. So here, angles 4 and 5 must also be the same. The opposite angles are congruent. So all of those are also 38. Okay. How are we going to figure out 1 and 2? (90 minus 38). Okay, so you're saying we have a right angle right here? Okay. All right, so if I have a right angle, we know that that's 90 degrees. And so we can figure out angle 1 by doing 180 minus 90 minus 38. Good. Okay, what did we get? 52. All right. And if that's 52, what should angle 2 be? 52 as well. Okay, so 1 is 52 and 2 is 52. So this was 180 minus 90 minus the 38 to get our angle number 1 right there. All right. And if 1 and 2 were 52, tell me about 7 and 6. They're also supposed to be 52. So those are also 52. And what's angle 8? 90. Good. All right, that's good, right? You good with that? Good? Okay. That 90-degree angle is really handy. Okay, so we're not ready. You think we're, well, let's turn the page. Let's turn the page. They're all like the same thing we did yesterday. Yeah, you do need to keep them straight, though. So, rhombuses also have a more specific rhombus. Special type of rhombus is a square. A square has all the properties of a parallelogram, rectangle, and rhombus. Of course, we know a square has all 4 sides congruent, all right? 4 congruent sides, absolutely. I'm going to, you know what, I just like to have a little picture that I can draw. Draw yourself a little square. We know all 4 sides are congruent. Very, very important. We also know, like a rectangle, all 4 angles are perpendicular. They are right angles, 90 degrees. 4 right angles. Also, like a rectangle, the diagonals are the same length. Those diagonals are congruent like a rectangle. And then like a rhombus, the diagonals are perpendicular. So that's a good one to know too. And those diagonals bisect each other and bisect their opposite angles. Okay? So lots of bisecting going on in a square. All right? Yeah. Yes, so all of these little angles have to be 45s. Because the diagonals start congruent, so if they're all like 10, then each little one here is going to be 5, 5, 5, and 5. So we have isosceles triangles, which means all of these little angles all have to be 45s. Yes. All the big angles are 90. Yeah, and all the little angles are 45. Except, Yeah, exactly. Yeah, we have parallel sides. So again, all of these alternate interior angles, they all match. They all have to be 45. So all those little baby angles in the corners are 45s. Okay. All right. So let's see. Let's look at number 7. PQRS is a square. So I know that all 4 sides are congruent and all 4 angles are right angles. And they tell me that TR is 17. Find each missing value. If TR is 17, what else is 17? PT is 17, ST is 17, TQ is 17. All those little baby diagonals are 17 because they all are the same length. All right, we want to find each missing value. How, let's see, what's PR? 34. QS is also 34. QT is 17. PQ. How do we find PQ? Pythagorean theorem. We have a right angle where the diagonals bisect each other. That's a right angle. So we have to use the Pythagorean theorem. So the x is our hypotenuse. So we want to do leg squared plus leg squared. 17 squared plus 17 squared equals our hypotenuse squared. So x squared. What is 17 squared plus 17 squared? 578 equals x squared. And then we take a square root of both sides. So we get x equals, all right, 24.0. Okay, cool. So PQ equals 24. That's pretty amazing. Which means all 4 sides also have a length of 24 as well. All right, let's look at angles. The measure of angle PRS. PRS is this little angle. What is it? 45, yes. The measure of angle STR. STR is right here is 90, yes. PSR. PSR is this whole angle S right here, also 90. And QPR. QPR is this little angle up here, 45. Yeah. Squares are easy. Yeah? All right. Squares are super duper easy. Okay, let's look at, let's see, number 9. All right, number 9. CDEF is a rhombus. You must read carefully today, ladies and gentlemen. You have a Delta Math assignment. Everything is all mixed up today, so you need to read carefully. Am I thinking about a parallelogram, a rhombus, a rectangle? They're all mixed, okay? So you need to read carefully. All right, so we have a rhombus. Find the measure of angle FED. So we're looking for this whole angle right here, the whole FED. What do we know about these 2 angles in a rhombus? They are congruent because, on the rhombus side, we know that the diagonals bisect the opposite angles. So those opposite angles get bisected. That's kind of a unique one. All right, so those are congruent little angles there. So what's our equation? 5x plus 1 equals 8x minus 20. Good, good, good. Let's see. I'm going to subtract 5x, so that gives me 3x. And I'm going to add the 20. So I get 21 equals 3x. And then divide by 3, I get x equals 7. And how do we figure out that whole angle FED? Plug it in. Plug in your 7. So I'm going to plug in my 7 right there. So I get 5 times 7 is 35 plus 1 is 36 degrees. So both of these should be 36 degrees. What do we know about the consecutive angles? Yeah, they're supplementary. So if this whole angle is 72 degrees, how do I figure out this whole angle over here?
180 minus 72.
Yeah, the measure of angle FED is going to be 180 minus 72, which is 108 degrees. Okay. All right. I think that's probably good. Yeah?
Yeah.
Yeah? Okay. All right. Keep those notes handy, ladies and gentlemen. You guys will have adults to math.